Hi folks, it's me again, and this is the last video for the practice quiz number 4. Please do take this quiz. I think it will help you. Which of these will produce a precipitation reaction? In other words, which of these is going to produce a solid? Well, to figure that out, you need to write down the products. Now, these are all ionic compounds. There are two of them in each of these choices. So that means we're going to get the double displacement or double replacement reaction. Do you remember this from podcast? I believe it was episode 9. So I'll underline the positive ions here. Now we'll switch partners. So Na is going with Cl. NH4 is going with NO3. We've encountered these guys in the solubility rules before. They are soluble, so there will be no reaction. Remember, you can only have a reaction here when a solid forms, or water forms, or a gas forms. In this case, we're only interested in the precipitation reactions, which is when solid forms. Here's the K, here's the Hg2. So the K will go with the NO3. I'm not even interested in balancing the equation, just interested in is it going to form a solid or not. The Hg2 will go with SO4. I know this is soluble because it has potassium, but what about Hg2SO4? What is SO4? SO4 is sulfate. So let's look at the rule. Where did the rules go? Ah, here they are. These are not the rules, these are the questions. Well, I need to get the rules. Excuse me, folks, as I go get the rules. Yes. Looking for quiz 4. This is the quiz that I'm looking for. Okay, here we are, the solubility rules. I was looking for mercury and for sulfate, mercury sulfate. Okay, sulfates are generally soluble. Exceptions, mercury sulfate. This is not the form of mercury that I saw in the problem, though. I saw the Hg2 form, but it looks like the Hg2 form is also typically forming a solid. So I'm just going to assume that since the Hg2 form forms solids, and also the Hg forms a solid when it's with sulfate, this must also form a solid. This Hg2 is mercury 1. It is a less common form of mercury than mercury 2, I think. But this is going to form a solid, so that means this is the correct answer. Let me see if there are any better answers than that, because I did have some uncertainty with this. I believe this forms a solid, so I believe this is the precipitation reaction. But what about this one? Cesium is an alkali metal, just like sodium is. You can see it here, cesium, in the first column. That means it's an alkali metal. That means anything it reacts with is also going to be soluble. Oops, keep on making stray marks, right? So CS is going to react with the OH, CSOH, and Na is going to be with the I, NaI. Now these are both alkali metal salts. Alkali metals are right there. So that means they're both soluble, no reaction. HCl and calcium hydroxide. You'll remember from the podcast that this is an acid, it starts with an H. This is a base, it contains OH. So acids and bases react to do the neutralization. In other words, they form water. There will be 2 of these, however, and 2 of these. So water is a liquid, it is not a solid. So, and this is dissolved in water. This is a soluble salt because it is a halide, a halogen salt, with a positive ion that is not iron, it is not mercury 1, and it is not the other exception. which I forgot. What was that other exception? Here it is. Not silver. It's good. Lead 2, silver, and mercury 1. These are the positive ions that will cause a solid to form when there are halide ions around, like chloride, bromide, or iodide. Okay, so anyways, that's B. I have confirmed by the process of elimination that B is the answer for this one. What about this? Phosphoric acid and carbonic acid in Coca-Cola. That was extraneous information. How many H plus ions can the acid, phosphoric acid, donate per molecule? Well, phosphoric acid has PO4. You know that PO4 is the phosphate ion. PO4 3 minus. This is something that you should have memorized. And if it is 3 minus, then it must have been countered by 3 H pluses in order to make this charge 0 for this neutral acid molecule. That means there are 3 H pluses, so it's H3PO4, you know. When this dissolves in water, it could make 3 H pluses. It doesn't always, but it could make 3 H pluses. So the answer is 3. What, as an extra here, what do you call an acid like phosphoric acid, which doesn't always separate completely, but could? Some of these could separate completely. That's right, it would be a weak acid. Photosynthesis is a redox reaction. What is being oxidized and what element is being reduced? Remember the mnemonic oil rig. Oxidation is losing electrons. Reduction is gaining electrons. So let's see. Let's assign oxidation numbers. Start with the oxygens here. They are -2. There are 2 of them, so 2 times -2 is -4. That means the carbon must be +4. That's his oxidation number. This oxygen is -2. There are 2 hydrogens, so each hydrogen must be +1. Now, this carbon is a little strange. It's necessary to know what is bonded to this carbon. Don't worry, on your real quiz, it won't be so opaque here. There will be ionic compounds here, or compounds that only have 2 elements. Those will be called binary compounds. So there will be binary compounds here, so that you cannot make any mistake. So now, this carbon is bonded to some other carbons, but it's also bonded to some hydrogens. And we need the actual structure of the molecule to see who's bonded to whom. Maybe I shouldn't have used that when I made up that practice problem. Okay, so here is a nice model of glucose. So each of these carbon atoms has an oxidation number. Let's see what it is. This carbon atom is bonded to 2 hydrogens, an oxygen, and a carbon. Now, the oxygen is -2, but the hydrogens are +2. So the oxidation number for this carbon is 0. You don't need to give this any oxidation number in order to have a total oxidation number of 0 for all the atoms bonded to this carbon. What about this carbon? Well, there's a -2 right there. It's +1 here, so this carbon's oxidation number is +1. Actually, this problem is going to have several different oxidation numbers for the carbon, so let me change this. This is not a good problem for your practice quiz. I am going to have to find another problem for your practice quiz. Let's see. I will use this one down here. Okay. In this chemical equation, the chlorate ion plus sulfur dioxide makes the sulfate ion and the chloride ion. Let me write that with handwriting because the superscript on sulfate got knocked out. Okay, so that's the chlorate ion plus sulfur dioxide makes the sulfate ion and the chloride ion. So, who is getting oxidized and who is getting reduced? Let's look at this chlorine. The total charge is 1 minus, so the oxidation states need to add up to -1. The oxygen, we assume, is -2. So 3 times -2 is -6. So the chlorine needs to be +5 because 5 plus a -6 equals -1 right there. This oxygen is -2 again. The sulfur is now +4 because there is no charge. Here, each oxygen is -2 again, so that's 4 times 2. That's a total of -8. So this sulfur needs to be +6 because 6 plus -8 equals the total charge of this molecule, which is -2 or 2 minus. This is an ion which only has one atom, so the oxidation state is automatically the same as the charge, -1. Looks like, I'll do this in a different color, looks like the chlorine went from +5 to -1. It went from positive to negative. That means it gained electrons. Reduction is gaining electrons. So Cl got reduced. Oops. Not rediced. Reduced. That means the other thing, sulfur went from +4 to +6. To become more positive, you have to lose electrons. So oxidation is losing. So sulfur got oxidized. All right, that's it. Now, the hardest problem here is balancing this redox reaction in acidic conditions. Remember, I used the WE method here, where WE stands for W, water, H, hydrogen ions, and E, electrons, in that order. You'll see in a moment here, if you don't already see. So it's chlorate plus sulfur dioxide makes the sulfate ion plus the chloride ion. The first half reaction is from chlorate to chloride. First, I balance everything that's not oxygen. Then I balance the oxygens by adding by adding the water. Okay, so I'm going to add 3 waters on this side only, so I can balance the oxygens. Now so that was W. Next is H. Now I balance the hydrogen ions by adding 6 hydrogen ions over here, since there are 6 hydrogen atoms over here. And then E, I add the electrons. So let's see, the total charge here is 6 plus minus 1. The total charge is +5. Total charge here is -1. So I'm going to have to add 6 electrons here so that I can get -1. So I'm adding 6 electrons. And I'm cleaning up my scratch work. Great! And now for the other half reaction. Sulfur dioxide makes the sulfate ion. Now I've got to add 2 water molecules here because water is first, and then hydrogen, and then electrons. So water is first because I just add these 2 water molecules because I want 2 more oxygens, because there are 4 oxygens here but only 2 oxygens here. The S was already balanced. And now I add hydrogens. There are 4 hydrogens here, none over here, so I add 4 hydrogens. And now I add electrons. Let's see. I have 4 plus and 2 minus. Total charge here is +2, or the total oxidation state is +2. Here it's 0, so I need to add 2 electrons over here to cancel this 2 out, so that this could also be 0. And there are 6 electrons over here in this half reaction, and only 2 electrons on this side, so I'm going to have to multiply everything on the latter half reaction by 3. So I can get 6 electrons. 2 times 3 is 6, 2 times 4 is 8, 2 times 1 is 2, 2 times 1 is 2, 2 times 2 is 4. Okay. And now I can combine the 2 equations. So I'll do that in purple for you so that this is less confusing, if that were possible. Now I'm going to combine these equations. Get some white space. Oops. Get a new white space here. I'm going to combine these equations by copying down stuff. So 6H plus 6 electrons plus a chlorate ion makes, those are the reactants, right? I'm not going to put the arrow yet. I'm going to write all the reactants at once, even these. So 4 waters and 2 sulfur dioxides. That beep is my dishwashing machine. Right. And now I write the arrow and I copy down all the products. You guys first over here. Chloride plus 3H2. It doesn't matter whom you do first here. And then these products over here. 2 sulfates, bunch of H plus ions, and 6 electrons. Now I start canceling stuff out, just like when you were working on your net ionic equation. These electrons I designed to cancel out, so they obviously cancel out. Any hydrogen ions? Yes, I can take 6 out of there and have 2 hydrogen ions left. 6 are gone, they cancel out. Anything else? Yeah, I got 3 waters here, 4 waters here, so one of these could three could cancel out, and I'll have 1 left. And that's it. The balanced redox reaction is the chloride ion, 2 sulfur dioxide gas molecules, making the chloride ion and 2 sulfate ions. This is done in acidic environment, so it's okay to have 2 H plus left over. To be strictly correct, you should put AQ on everything that you see here, except for the sulfur dioxide gas. It's important to know how to figure out if this is a gas or a liquid or AQ. If it's not charged and everything else is charged, this is probably either a solid or AQ. If it's not an ionic compound, it's probably a gas. Did I say solid? So if it's not charged, it's probably solid or gas, not AQ. Now this is not charged. This has no metals in it, so it's not an ionic compound. It is a molecular compound. And molecular compounds tend to be gases. They do not have strong enough attractions to each other, but that is an explanation for another module. Thank you, folks. I know that last problem was hard. There is practice in the WebAssign and a worked example in your textbook. If you need more practice before you schedule this quiz with Examity, or before you schedule your exam with Examity, please contact me. You know where to find me. I'd be delighted to give you more practice and to go through it with you. Thank you. Oh, by the way, folks, I have not received many comments about the podcast lately, so I'm just going to assume that you're maybe not listening to it, or maybe just not benefiting from it. I might taper off on podcast episodes, but I will get right back on to making podcast episodes and more podcast episodes if you tell me that they're helpful. Okay, thank you.